Good afternoon, everybody. Here, I would like to welcome you all in this lecture of BCME2, that is BME, Basic Mechanical Engineering. And today, we are going to start unit number 8 purposefully because this unit is very big and very, very important. And I think in the 12th standard, you might have learned the concept about this unit also. The name of unit is thermodynamics. I think in the 12th standard, you have learned this particular chapter in the chemistry, thermodynamics might be. Have you learned it?
Yes, sir.
Yes, sir.
Have you learned this thermodynamics in the 12th standard?
Yes.
Yes, sir.
You can reply me in the chat box. Yes, you have learned it. So, many concepts, as far as this unit is going to be concerned, is already studied by you people. But the same chapter, we are going to learn according to engineering point of view. As far as mechanical engineering is going to be concerned, ज्यावेळी मेकॅनिकल इंजिनिअरिंगच्या ब्रांचचा विचार होतो त्यावेळी तुम्हाला असं दिसेल की थर्मोडायनामिक्स इज इन्क्लुडेड इन युअर सिलेबस स्पेशली इन दी बेसिक मेकॅनिकल इंजिनिअरिंग ॲज अ युनिट. एक चॅप्टर म्हणून तुमच्या या बेसिक मेकॅनिकल इंजिनिअरिंगच्या सिलेबस मध्ये हा जो चॅप्टर आहे तो चॅप्टर ऍड केलेला तुम्हाला सगळ्यांना दिसतोय. When you will go to the second year of the mechanical engineering, you will come to know that there is a whole subject named as applied thermodynamics. Second year मध्ये पूर्ण एक सब्जेक्ट आहे स्पेशली based on this thermodynamics, and name of this subject is applied thermodynamics. When you will go to the third year, then you need to study subject HMT, heat and mass transfer, which is the extended version of this thermodynamics. And in the final year, you are going to learn the subject refrigeration and air conditioning. That is also extended part of thermodynamics. That's why this chapter is very much important. मेकॅनिकल इंजिनिअरिंगच्या ज्या स्ट्रीम मध्ये थर्मोडायनामिक्सचा अभ्यास केला जातो त्या स्ट्रीमला पॉवर इंजिनिअरिंग किंवा हीट ग्रुप असं म्हटलं जातं. हीट अँड पॉवर इंजिनिअरिंग. हीट अँड पॉवर इंजिनिअरिंग मध्ये दिस थर्मोडायनामिक्स इज गोइंग टू प्ले व्हेरी इम्पॉर्टंट रोल. दिस थर्मोडायनामिक्स इज अ बेसिक फॉर ऑल दीज डिटेल्स, अँड दॅट्स वाय learning thermodynamics is very, very important. You have learned already this subject. You have told me accordingly also. So the content which we are going to learn under this particular unit is definition of thermodynamics, then thermodynamic systems, surrounding, universe, types of the system, state of the system, properties of the system, that is intensive and extensive. These part related with the system we are going to learn first. Means we are going to understand what does exactly meaning of this particular word system. What is surrounding? What do you mean by universe? Which are different types of the system? State of the system, and there are some properties of system too. Those things we are going to learn here. The next concept which we are going to learn is a thermodynamic equilibrium. A body is said to be in a thermodynamic equilibrium. कधी thermodynamic equilibrium मध्ये येते body? What is the process in the thermodynamics? What do you mean by the cycle or the cyclic process? And then zeroth law of thermodynamics we are going to learn in the first part of this particular unit. The first part मध्ये we are going to learn these all concepts. In the second part, we are going to apply this knowledge gained in the first section to study the work and the heat and its relation. Heat, work, आणि त्याचं जे काही relation आहे, that relation we are going to study under this 1.2. And the content are work and forms of work, heat, first law of thermodynamics, first law applied to the flow process, steady flow process, steady flow energy equation, and the numerical based on it. We are going to learn in the point number 2 in the second part of this particular unit. And in the third part, we are going to learn limitation of the first law, then Kelvin and Planck and Clausius statement of the second law of thermodynamics. The पहिला law thermodynamics मध्ये असणाऱ्या important definitions, work आणि heat मधलं relation, आणि त्यानंतर limitation of the first law and second law of thermodynamics we are going to learn under this particular unit. This syllabus I have dictated at the beginning only. You need to leave some lines to write this particular syllabus, and then in the bit by bit notes we are going to start discussion regarding with this particular chapter. Now here there is an introductory slide, and in that introductory slide the word written as a title is thermodynamics and energy. दोन शब्द लिहिलेले आहेत तिथे, thermodynamics and energy. So what do you mean by thermodynamics? Thermodynamics is the science of energy. एनर्जी म्हणजे काय? ऊर्जा, बरोबर आहे. And science of energy means what? ऊर्जेच्या पाठीमाग असणारं विज्ञान म्हणजे thermodynamics. Mainly we are getting the energy in the form of heat, and that's why we can see that in the thermodynamic heat is playing very important role, because thermodynamics is nothing but the science of energy, and many times we are getting energy in the form of heat. उष्णतेच्या स्वरूपामध्ये बऱ्याच वेळा आपल्याला जी ऊर्जा आहे ती ऊर्जा मिळत असते. Then here, as far as energy point of view, the thermodynamic word is clearly mentioned over here. मी आत्ताच म्हणालो की हीटच्या फॉर्म मध्ये जी एनर्जी मिळते ती आपण मोठ्या प्रमाणामध्ये वापरतो. And here it is written that the name thermodynamics means stems from the Greek word therme and dynamis. So the basic of this particular word is nothing but the Greek word. याचं जे मूळ आहे तो एक ग्रीक शब्द आहे, आणि ते एक ग्रीक शब्द म्हणजे तो ग्रीक शब्द जो आहे तो दोन शब्दांचा मिळून बनलेला आहे. पहिला शब्द आहे थर्मे, थर्मे मीन्स हीट, आणि दुसरा शब्द आहे डायनामिस और डायनामाइस, आणि डायनामाइसचा अर्थ आहे पॉवर. सो दिस सायन्स रिलेटेड विथ दी एनर्जी, especially in the form of heat and conversion of heat into power, that particular study is nothing but the thermodynamics. Okay, so in the thermodynamics energy we are getting in different form, not only in heat form. फक्त हीटच नाहीये, वाऱ्यामधून आपल्याला ऊर्जा मिळते, उष्णतेमधून ऊर्जा मिळते, आपल्याला समुद्राच्या लाटांपासून ऊर्जा मिळते, आपल्याला केमिकल रिएक्शन्स मधून हीटच्या फॉर्म मध्ये ऊर्जा मिळते. सूर्यापासून सूर्यप्रकाशाच्या माध्यमातून हीट मिळते आणि त्या माध्यमातून ऊर्जा मिळते. सो मेनी सोर्सेस आर देअर अबाउट प्रोव्हाइडिंग द एनर्जी or providing the heat to we people. Now, the second point is about conservation of energy. So, what is the law of conservation of energy? ज्याला आपण ऊर्जा अक्षयतेचा नियम असं म्हणत होतो 10वी पर्यंत. What do you mean by conservation of energy? Energy can neither be created nor be destroyed, and the total amount of energy in the universe is always remain constant. त्याला आपण ऊर्जा अक्षयतेचा नियम म्हणलेला आहे. काय की ऊर्जा निर्माण करता येत नाही, ती नष्टही करता येत नाही, तथापि ऊर्जेचे एका रूपातून दुसऱ्या रूपामध्ये रूपांतरण करता येते आणि विश्वातली एकूण ऊर्जा ही अक्षय असते, असा तो मराठीमध्ये ऊर्जा अक्षयतेचा नियम होता. That is the conservation of energy principle. Means energy cannot be generated, it cannot be destroyed. Only we can change it from one point to another, one form to another form. So here it is shown in this diagram with the excellent example. इथं तुम्ही पहा एक खूप छान एक्झाम्पल या ठिकाणी सेट केलेला आहे. व्हॉट इज दॅट एक्झाम्पल? चेक. Here the potential energy P is a 10 units because the stone is steady at that particular position. Let us say this is point A. At point A, you can see that the stone is steady. एखादी गोष्ट स्टेडी आहे याचा अर्थ काय आहे की तिथं पोटेन्शियल एनर्जी, स्थितीज ऊर्जा ही मोठ्या प्रमाणामध्ये साठवली गेलेली आहे. तिथं ती स्थितीज ऊर्जा प्रेझेंट आहे. When you will throw such big stone from a certain height, due to effect of the gravitational force, it will come down towards the land, towards the earth surface. वरनं तुम्ही त्याला जस्ट धक्का दिला की ते खाली पडणार आहे आणि खाली कुठं पडणार आहे? हे जमीन आहे. त्या जमिनीचा पॉइंट त्याला आपण म्हणू बी पॉइंट. सो इट विल रीच टू दी पॉइंट बी. पॉइंट बी ला जे काय आहे ते स्टोन जो आहे तो येऊन त्या ठिकाणी थांबणार आहे. So you can see that potential energy was 10 units. 10 unit होती potential energy. And now this potential, when the stone is coming towards point B, when stone is falling from certain height, what is going to happen? Potential energy is going to decrease and kinetic energy is going to increase. So at point A, kinetic energy was 0, potential energy was 10 units. Now, after in the falling condition, after traveling some distance, दगड फेकल्यानंतर काही अंतर गेल्यानंतर तुम्ही पाहू शकता potential energy is reduces, it is 7 units. And kinetic energy is increasing, it is reached to the 3 units from 0 to 3. किती झालेलं आहे? 0 to 3 झालेलं आहे. लक्षात घ्या. Means kinetic energy is increased and potential energy is decreased. Now you will have to tell me when your stone will reach at B, your potential energy will be
10 units.
How much? It will be 0. Absolutely correct. And what will be your kinetic energy?
10 units. 10 units. 10 units.
It will be 10. म्हणजे कुठं असणार आहे? जस्ट जमिनीला टच करायच्या आधी.
Yes, sir.
एकदा ती पुन्हा दगड येऊन जमिनीवर आदळला आणि तिथं स्थिर झाला की परत तिथं पोटेन्शियल एनर्जी 10, कायनेटिक एनर्जी 0. Means just little some distance away from the ground, potential energy will become 0 and kinetic energy will be 10 unit. Means if you will find out the total energy, it is 10 units in every condition. Here also it is potential energy 10 units. Here potential energy 7 plus kinetic energy 3 means 10 units. इथून काही अंतर खाली गेल्यानंतर पोटेन्शियल 5 झाला असेल, कायनेटिक 5 झाला असेल. वन्स अगेन इट इज 10 युनिट्स. आणि ज्यावेळी जस्ट जमिनीवर पडायच्या आधी काही डिस्टन्स, कायनेटिक एनर्जी 10 युनिट्स. Means total amount of the energy in that particular system is always remain constant. Have you understood that part? How energy always remain constant? It can change from one point to another. एका फॉर्म मधून दुसऱ्या फॉर्म मध्ये त्याचं इझिली जे काही आहे ते ट्रान्सफर होते. But total amount of energy is always remain constant. And the same condition is explained in the first law of thermodynamics. म्हणजे एनर्जी कॉन्झर्वेशनच्या संदर्भामध्ये जो लॉ आहे, लॉ ऑफ एनर्जी कॉन्झर्वेशन, द सेम लॉ इज ऍज इट इज एक्सेप्टेड in the form of first law of thermodynamics. First law of thermodynamics काय आहे? तर first law of thermodynamics is nothing but the law of conservation of energy. Okay, so this is the introductory slide as far as thermodynamics chapter is going to be concerned. I request you, please immediately write it down, the introduction, and draw this particular diagram to understand energy conservation at any condition and in any case. Here especially kinetic and potential energy they have shown to us. Okay, but everywhere you can see that this energy conservation happens, and that's why work is carried out. Most of the energy is transferred in the form of the heat. Okay, and that's why we need to study the thermodynamics. I request you write it down and then draw this diagram also in your notebook. Draw a rough diagram. Have you started it? Have you started it? Yes. Okay.
Yes, sir.
Okay. Go on. Draw it fast. So here we are going to discuss the first law of thermodynamics. The first law of thermodynamics is an expression of conservation of energy principle. I already said it to you. It is nothing but energy, law of energy conservation. The first law asserts that energy is a thermodynamic property. ही जी एनर्जी आहे, ही एनर्जी ही एक थर्मोडायनामिक थिंग आहे असं फर्स्ट लॉ ऑफ थर्मोडायनामिक्स आपल्याला सांगतो. And the second law of thermodynamics, it asserts that energy has quality as well as quantity. म्हणजे जी काही तुमची एनर्जी आहे त्या एनर्जीला सुद्धा एक क्वालिटी आहे, दर्जा आहे, ग्रेड आहे. And it has quantity, means it can be measurable. एनर्जी काय करता येते? त्याचा दर्जा पण तपासता येतो आणि ती मेजरेबल आहे. म्हणजे एवढी एनर्जी तेवढी एनर्जी तेवढी एनर्जी. काही गोष्टी मेजरेबल असतात, काही गोष्टी मेजरेबल नसतात. ओके, इझिली मेजरेबल काही गोष्टी नसतात. फॉर एक्झाम्पल माती तुम्हाला मेजर करायची, you can measure it easily. You can take a soil in your hand, you just put it in the balance and you can check it how much weight of that particular soil is. But can you take air in your hand and can you measure? मी आता हातात एवढी हवा घेतली आणि ह्याचं वजन 10 किलो आहे. No. Means at normal condition we cannot measure always the quantity, or in some case we cannot check the quality also. But as per the second law of thermodynamics, energy, in case of the energy, we can check quality of energy also and quantity of the energy also. Okay. And according to second law, it is also explained that the process of energy transfer is always in the direction of decreasing quality of the energy. एनर्जी कशी आहे बघा, एनर्जी नेहमी त्या दिशेने वाहते ज्या दिशेने वाहिल्यानंतर त्याची जी क्वालिटी आहे ती क्वालिटी ही चेंज होते, क्वालिटी डिक्रीज होते, अशा ठिकाणी ती वाहते. म्हणजे always decreasing when any process is going to be happen. And here it is shown by some example. तुमच्या घरामध्ये तुम्ही छानपैकी एखादी कॉफी तयार केली, सनराइजची असेल, नेसलीची असेल वगैरे वगैरे, आणि ती कॉफी तयार करून गरम गरम कपात ओतून ठेवली आणि मला सांगा तो कप असाच ठेवून दिला आणि पुन्हा 10 मिनिटांनी तुम्ही त्या कपापाशी गेलात, काय जाणवतं तुम्हाला? त्यातली कॉफी कमी होते का? नाही होत. कॉफी कमी होते का?
नो सर.
तसलं कॉफी बिफी आम्ही पित नाही असं काय म्हणू नका. कॉफी कमी होते का एवढं सांगा. नाही होत. ओके, ग्रेट. कॉफी काही कमी होत नाही. सो हसा लागले सगळे तिकडं. सो you can see that the temperature of your coffee is getting decreased. Okay, it is try to reach at its cool condition. Means if the temperature of coffee it is 70 degrees centigrade, then coffee is rejecting the heat to the atmosphere because atmospheric temperature is 20 degrees centigrade. वातावरणाचं टेम्परेचर 20 डिग्री आहे. मग टेम्परेचर हॉट बॉडी कडून कोल्ड बॉडी कडे कधीपर्यंत जाणार? जोपर्यंत कॉफीचं टेम्परेचर 20 डिग्री होत नाही तोपर्यंत. Means energy in the form of heat is rejected in the heat transfer process. Temperature is getting decreased means the quality of the energy is also getting decreased. Okay, that part you will have to understand. Okay, means heat is flowing in the direction of decreasing the temperature of your prepared coffee. ह्याच्यावर सरळ सरळ कळतं की एनर्जी कुठं फ्लो होत असते, क्वालिटी डिक्रीज करण्याकडे फ्लो होत असते, जास्तीकडून कमीकडे फ्लो होत असते. उलट कधीच जात नाही, कमीकडनं जास्तकडे होत नाही. कमीकडनं जास्तकडे जर त्याला पाठवायचं असेल तर त्याच्यावर वर्क करावं लागतं. यू विल हॅव टू डू work. You will have to provide the external support. Okay, then it is possible from low temperature to high temperature energy passing. It is possible, but you need some efforts for that. तर पुढे तुम्हीच म्हणणार मला, मी रेफ्रिजरेशन शिकवायला लागल्यानंतर तुम्ही तर म्हणत होता लो बॉडीकडनं हाय बॉडीकडनं टेम्परेचर पास होत नाही, मग रेफ्रिजरेटर मध्ये कसं पास होतं? तर तेच आहे, वर्क जर बाहेरून तुम्ही प्रोव्हाइड केलं तर ते सुद्धा आपल्याला घडवता येतं. बट यू नीड टू प्रोव्हाइड द एक्सटर्नल वर्क. बट इन केस ऑफ द कॉफी, द हीट ट्रान्सफर इज द नॅचरल फिनॉमिना. नैसर्गिकरित्या ते होतं. We are not going to apply any external source of the energy in the process. बाहेरून आपण काही एनर्जी प्रोव्हाइड करत नाही किंवा वर्क कॅरी करत नाही. So, as per the second law of thermodynamics, which asserts that energy has quality as well as quantity, and actually process occur in the direction of decreasing quality of energy. Is it clear to everybody now? Is it clear to you? Yeah. When you will check the first law of thermodynamics related with the human body, what exactly happened, we can see. We are receiving the energy in the form of the food. Say you have received energy 5 units. आपण 5 युनिट एवढी एनर्जी घेतली. युनिट म्हणतोय मी, एनर्जीच्या युनिट मध्ये ते किती मध्ये वॅट आहे, जेम काय ते किलो वॅट आहे, मेगा वॅट आहे, मला आत्ताच त्यात जायचं नाहीये. आत्ताच तुम्हाला कन्फ्युजन स्टेट मध्ये आणायचं नाहीये. ते जूल आहे का किलो जूल आहे का मिली जूल आहे, मला त्याच्यामध्ये काहीच तुम्हाला आत्ताच ड्रॅग करायचं नाहीये. सो दॅट्स व्हाय आय हॅव युज्ड द वर्ड युनिट. सपोज यू हॅव टेकन फूड, मीन्स यू आर गेटिंग द एनर्जी. And you are performing some work. असं समजा की मी क्रिकेटर आहे आणि सध्या मी कसोटी खेळतोय श्रीलंकेच्या विरोधात. तर मी काय करतोय, सकाळी उठल्यानंतर ब्रेकफास्ट घेतोय, मीन्स आय एम टेकिंग एनर्जी अँड आय एम युजिंग दॅट एनर्जी फॉर द बॅटिंग पर्पज. ओके, मी काय करतोय, बॅटिंग करण्यासाठी त्या एनर्जीचा वापर करतो. अँड आय एम ऑन द पिच अँड आय हॅव प्लेड अप टू द लंच आवर अँड आय हॅव मेड सेंचुरी. ओके, अँड यू कॅन सी दॅट अप टू द लंच आवर इफ आय विल प्ले, आय विल बी गेट एक्झॉस्टेड. व्हाय आय एम गेटिंग एक्झॉस्टेड? Because to perform the action, to perform the work, I am using the energy taken in my body. Say 4 unit energy out of that 5 unit I have spent for the batting. Batting साठी 5 पैकी 4 म्हणजे 80% एनर्जी मी वापरली. मग लंच का गरजेचं आहे? कारण लंच पर्यंत खेळून खेळून माझी जी एनर्जी आहे ती आता 20% शिल्लक राहील. Once again in the lunch I will go, I will take some fruits, I will take some milk, I will take some light food, and once again when I will take food, means once again when I will take energy, then I will be charged. एकदम मला फ्रेश एनर्जेटिक वाटायला चालू होतं. Why it is so? Because I am getting charged. And once again I will use that energy and I will play remaining whole day. I will make a double century at the evening by using that. Okay, so here you can see that humans are taking energy in the form of the food. They are performing some action, they are performing the work. During that work, energy is means there is a loss of energy, and once again we are collecting the energy from the food source or some energy drinks. Okay, like glucose or some energy drinks are there. Mainly the sportsmen are using it. ते काय आपल्यासारखं पाणी डेऱ्यातलं काढून तिथे येऊन ग्राउंडवर पित नाही. एनर्जी ड्रिंक असतं, ते कलर्ड असतात, वेगवेगळे फ्लेवर असतात. ते जास्त प्रमाणामध्ये एनर्जी मिळावी म्हणून ते ग्लुकोजचं पाणी वगैरे ते घेत असतात. ओके, व्हाय इट इज? because they require more energy to perform the work. And here you can see that energy is coming inside the body through the food, and energy is going out through the body when you are performing some action. Work is nothing but force into displacement. That is the physical thing. When you will apply some force and when you will go for the displacement with that force, work will be carried out. रन काढण्यासाठी मी पळतोय, वर्क विल बी कॅरीड आउट. कारण बॉडीचं वजन, माझ्या बॅटचं वजन, हे सगळं घेऊन मी पळतोय, वर्क विल बी कॅरीड आउट. सो conservation of the energy principle, taking the energy, using the energy, again taking the energy, it is happen in the human body also. Is it understood to you? This is also the introductory part, no need to write, just you can take the screenshot, that is sufficient. It is just for your understanding purpose, how energy works. Okay, now the third point is about the energy. या एनर्जीचा एवढा परिचय आपण करून घेतला, पण नेमकी एनर्जी 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 म्हणतात, ती एनर्जी काय आहे? ऍडव्हर्टाइज होते, बूस्ट इज द सिक्रेट ऑफ माय एनर्जी, ह्युमन बीइंग वी आर टॉकिंग अबाउट. बट व्हाट डू यू मीन बाय एनर्जी? होल वर्ल्ड इज नाउ in search of energy. We are getting energy for the industry through the petrol, diesel, such kind of the energy sources. ते ज्यांच्याकडे पेट्रोल आणि डिझेलचे साठे आहेत ते जगाचे मालक आहेत. Means you can see that everything is related with the energy. Social, political, economical, related with the knowledge, means educational things. All things are related with the energy. Okay, but that is in a different concept or context. Here we will study energy in the form of thermodynamics, in the context of thermodynamics. Okay, energy can be defined in only 4 words, that nothing but capacity to do work. कार्य करण्याची क्षमता म्हणजे energy. That is the definition of the energy, we can say. Energy can be defined as capacity to do work. Okay, and then there are 2 types of the energy. Number 1, internal energy and external energy. कुठल्या 2 एनर्जी आहेत? इंटरनल एनर्जी आणि एक्सटर्नल एनर्जी. अंतर्गत असणारी ऊर्जा आणि बाह्य ऊर्जा, अशी 2 एनर्जीचे प्रकार आहेत. What do you mean by internal energy? The internal energy is present in the system due to molecular motion, arrangement of atomic structure and its chemical composition. Okay, कशा कशामुळे इंटरनल एनर्जी एखाद्या बॉडी मध्ये जनरेट होते, माणसामध्ये नाही, एखाद्या बॉडी मध्ये जनरेट होते. नंबर 1, ड्यू टू molecular motion. We know that the molecule of every material is always in a moving condition. Molecular हे कधी कसे असतात? व्हायब्रंट असतात. मॉलिक्यूल हे कसे असतात? तयारच असतात मोशन करण्यासाठी. Then second is the arrangement of atomic structure. Arrangement of atomic structure means each and every atom is having certain atomic structure. Do you know atomic structure? You might have learned in the physics. Atomic structure शिकलाय का? लक्षात आहे का? काय? Anybody can tell me atomic structure?
Yes,
Do you know how the atomic structure is? Have you studied it in physics?
yes.
Yes. Can you tell me, Tanvi? Can you tell me the short forms of the atomic structures? शिकले तर सगळे म्हणतात atomic structure कोणता आहे? Electron, proton, neutron. One person is telling the answer electron, proton, neutron is the atomic structure. Okay. At a certain level, It is true. Okay. So when neutron, proton, electron, the structure of the nucleus, then proton and neutron are situated in the nucleus, and electrons are always in a moving condition. And these electrons are outer orbit electrons are always try to be get its complete stage. Okay. प्रत्येकामध्ये काहीतरी मला वाटतं 2, 8, 18 आणि 32 का 36 अशी काही इलेक्ट्रॉन्सची संख्या आहे बाहेरच्या कक्षेमध्ये फिरणारी. तर जेवढे इलेक्ट्रॉन्स कमी पडतात तेवढे इलेक्ट्रॉन्स घेण्याच्या दृष्टीने तो ॲटॉमिकचा जो पॉइंट एक ॲटम आहे तो दुसऱ्या ॲटमशी लगेच संयोग पावतो. And that's why different kinds of the molecular structures are or can be taken place. It's okay. I don't want to go in that detail. This is part of the chemistry or physics. I am not master of it. But second thing, after the atomic structure, we will think about the chemical composition. What do you mean by chemical composition? Chemical composition means how a system is prepared. Okay. And due to that, molecular motion, arrangement of atomic structure, and the chemical composition, we can see that here there are mainly 3 important types in chemical energy part, atomic energy part, and molecular internal energy part. म्हणजे जे 3 पॉइंट आहेत, molecular motion, arrangement of atomic structure आणि chemical composition, या 3 पॉइंट्सशी रिलेटेड 3 टाइपच्या ज्या एनर्जी आहेत त्या एनर्जीचं कॉम्बिनेशन म्हणजे इंटरनल एनर्जी. Now you can see that here the chemical energy is related with the chemical composition. Atomic energy is related with the arrangement of atomic structure. And molecular internal energy is related with the molecular motion. Means due to these 3 reasons, there are 3 types of the internal energy. And total summation of chemical energy, atomic energy, and molecular internal energy is considered as a total internal energy of the system. म्हणजे तुम्ही जर एक सिस्टीम असाल तर तुमच्यामध्ये असणारे जे काही मॉलिक्युल्स आहेत त्या मॉलिक्युलची मोशन, तुमच्यामध्ये जे ॲटम आहे त्या ॲटमचं स्ट्रक्चर आणि तुमच्या बॉडीमध्ये असणारी केमिकल कंपोजिशन विल डिसाइड युअर इंटरनल एनर्जी. दॅट्स ऑल. So in the energy, first of all, today we have studied the introductory part of first law of thermodynamics, second law of thermodynamics, definition of energy, and what do you mean by exactly internal energy. These bits up till now we have studied. So I request you, write it down, this introductory part with the energy and internal energy in your notebook immediately. Do it fast. Don't waste the time. Okay. We'll move towards next slide. We have learned about the internal energy now. Now, we have noted down the 3 parts of the, or 3 subtypes of the internal energy. Chemical energy, atomic energy, and molecular internal energy. Now we will study in detail what do you mean by chemical energy, what do you mean by atomic energy, and what do you mean by molecular internal energy. So chemical energy, it is the energy released due to change in a chemical composition. कुठल्याही ऑब्जेक्टचे केमिकल कंपोजिशन असतं. H2O, water, NaCl, मीठ, सोडियम क्लोराइड, NaCl plus H2O केल्यानंतर जे काही मिठाचं पाणी वगैरे तयार होतं. But when any reaction is carried out, then in that reaction, some chemical energy is going to be get released. म्हणजे पेट्रोलचं सुद्धा एक chemical composition आहे. But when the petrol is brought into the contact of heat, and when petrol will start its combustion, then energy is going to be get released. That is the chemical energy. एखाद्या केमिकल मध्ये असणारी एनर्जी जी त्याच्या केमिकल कंपोजिशन मुळे आहे त्याला म्हणायचं केमिकल एनर्जी. Then second is atomic energy. When atomic structure is going to be changed by the fusion process or fusion process. तुम्ही शिकलेला असाल atomic energy मध्ये ते युरेनियम 235 234 याच्यामध्ये वगैरे फ्युजन अँड फिजन प्रोसेस की you will have to break the nucleus of the atomic material or atomic elements like uranium, plutonium, etc., etc. When you will bombard alpha, beta, or gamma rays on the nucleus of such a atomic elements, the nucleus is going to break and lot of heat energy is released. We have seen, we have, means you have not experienced, I have also not experienced, but in the history it is mentioned the atomic bomb spot situated happened in the Japan during Second World War, Hiroshima and Nagasaki. In the Russia there is a part Chernobyl which is now under huge discussion, situated near Ukraine, I think, that Chernobyl. There was an atomic energy plant and there was a leakage at one plant due to accident. And you can see that still the radiation effect is situated in the Chernobyl. Means when you are going to break the nucleus of the material due with a fusion or fission process, lot of energy is going to be released, get released. That energy is nothing but atomic energy. Next is molecular internal energy. Molecules means when two or more elements you will bring together, the molecular structure will form. And these molecules are always in a moving condition. If you will provide heat, if you will provide or you will pass the current through any metal, the molecular motion will be increased. And due to that motion, whatever energy is going to be get released, that energy is molecular internal energy. Okay. It is very, very difficult to evaluate the absolute value of internal energy. फक्त आणि फक्त इंटरनल एनर्जी केवढी आहे तेवढीच काढा. केमिकल एनर्जी विचारात घेऊ नका, ॲटॉमिक एनर्जी विचारात घेऊ नका, मॉलिक्युलर इंटरनल एनर्जी विचारात घेऊ नका, असं घडत नाही. कमी जास्त प्रमाणामध्ये इंटरनल एनर्जी मध्ये केमिकल एनर्जी, ॲटॉमिक एनर्जी आणि मॉलिक्युलर इंटरनल एनर्जी या समाविष्ट असतात. या सगळ्याचं कॉम्बिनेशन म्हणजेच इंटरनल एनर्जी. And that internal energy is denoted by the letter capital U. Internal energy is denoted by letter capital U. Okay. So this is the information, detailed information about three types of the, or three subtypes, parts of the internal energy. I once again request you, write it down in the notebook immediately. So friends, here I'll stop my lecture. Have a nice day. Enjoy the evening. Bye bye.